promised, I'm very ready now. Oh my gosh. To my exercise. Oh my gosh. But before that, I need to do the very short live stream. I will give you one example of how to compute or calculate problem solving with regards to using saturated steam table. Okay, something like that in thermodynamics or thermochemistry. Wait for a while, ha. So in this problem solving, we're gonna have the interpolation. You know the interpolation? Since if you cannot determine the exact quantity through those given properties that you obtained in the steam tables, then you will be able to interpolate. You will undergo interpolation process. It's very necessary, especially if you're referring to various kinds of tables and graphs, and then you need to have the exact property for that particular reference quantities also, okay? Something like that, my gosh. So here it is. A rigid tank contains 10 kg of water at 60 degrees Celsius. If 7 kg of water is liquid form and remaining in vapor form, determine the volume of the tank. So in this case, it is very obvious that it is having two states, from liquid and then change to vapor phase. And then the word saturated is very clear also. So it's gonna be using the steam table, okay, in this kind of situation, okay. Though it was not mentioned that there is heat, okay, energy being mentioned there, but only the volume. But you can feel the problem that it's still thermochemistry or thermodynamics by using the steam table. Okay, let's solve now. I'm gonna get my blank sheet of paper. Oh my god, this is time limited. I have to make fast. Wait for a while. Okay, so the problem looks like a little bit difficult, but it's not. Okay, but there are also problems look like easy and average, but it seems to be difficult. You cannot guess through the appearance or through the given unless you will read it and analyze it by your own. Okay, oh my gosh. Oh my gosh. So the first thing to do is to jot down the given, okay, for the data. So given for this rigid tank contains 10 kilogram. So this is gonna be the mass total of the liquid water and the water at vapor phase. Okay, so this is mass total is equals to 10 kilogram. Okay, it's here. Temperature is 60 degrees Celsius. Okay. Okay. And then there's a remaining vapors. Okay. Obviously, so determine the volume of the tank. So determine the volume of the tank. This is volume total. Okay. Like this. Only the given is like this. Okay. And there's also 7 kilogram water. So this is gonna be our MF, right? The mass of liquid, or MF, is equals to 7 kilograms, something like that, okay? So you will use first formula that is easy to solve first before going to the table, right? So for example, you need the dryness fraction. If you talk about change in phase from liquid to vapor, what comes in your mind is a dryness fraction, really, the x, the small letter x, okay, the mass fraction, shall we say, in chemistry. But here specific name is dryness factor or dryness fraction. Okay, so let's x, okay, x is equals to mg over mg plus mf. Okay, here x is equals to mg over mg plus mf. So mass of the vapor over mass of the gas plus the mass of the liquid. Okay, now we have the total mass is 10 kilogram. So Total mass is equals to the mass of the gas plus mass of the liquid. So we have 10, oh my gosh, is equal to mass of the gas in which you don't know. Okay. And then the mass of the liquid in which you know, that is 7 kilogram. Okay. Then by algebra, you can solve for the mass of gas. It equals to 3 kilogram. Okay. So you have now the mass of gas, which is 3 kilogram. 10 minus 7. Okay. Now automatically you can get the dryness fraction without looking to the steam table. Okay, so X, oh my gosh, like that. X is equals to mg, the mass of the gas or the vapor is 3, okay, kilogram, plus the total mass, which is 10 kilogram. Cancel, cancel. So this is a fraction, so no more unit. So unit less. Okay. So 3 divided by 10 is equal to, calculator please, but this is 0.30 for sure. Okay. Like this. We have now a dryness fraction of 0.3. So you should establish that first, the dryness fraction, because it's very usable in the computation of the properties. Okay. In steam table, such as the specific enthalpy, the specific volume, specific entropy, and the specific internal energy. Okay? So it's always be used in that formula. That's why you need to compute first the dryness fraction. Okay? Now we go to, since we need to determine the volume of the tank, so we need to focus on the specific volume first. Unless we are required to find the specific enthalpy, internal energy, or the entropy, then this is volume, right? Go first for the volume. Do not waste your time to the quantities and properties that you are not asked. Okay? Something like that. So go back now. So watch which steam table we will be using. We will use the temperature-based steam table because it's mentioned the temperature. If it mentions the pressure, then go to the pressure-based steam table. But this time, we will be able to use the temperature-based steam table. Okay? Now, that is 60 degrees Celsius. It's here in the steam table. Okay? So, it's here. Temperature, 60 degrees Celsius. I will mark here. Okay? Just a highlighter. Okay? To make it easy. Oh my gosh, use my highlighter. Charot. Like this. Oh my gosh. So I marked or I highlighted with the light blue at 60 degrees Celsius. So this is gonna be the properties that we'll be able to use. But we must focus first for the specific volume because that is being required to the problem. Okay. Our specific volume in cubic meter per kilogram in the vapor state or VG, okay, at 60 degrees Celsius, of course, okay, is equal to, oh my gosh, 7.6672. 7.6672 cubic meter per kilogram. Okay, and our specific liquid state volume, specific volume at liquid state VF is equal to, okay, it's equal to VF 0.00 okay, 101,713 cubic meter per kilogram. Okay, this one. So if you see there's a subscript G and F, guys, these are automatically specific. Okay, specific volume of liquid state VF, specific volume of the gas state VG. This is not the regular volume or total volume what we mean, and in fact this is not a change in volume. Okay, now the question is determine the volume of the tank, meaning the total volume of the tank in which this liquid state and vapor are inside. Okay, you know the point, because it's not specified that there's a, escape of the molecules in the tank, because it's not specified that the tank is open. Really? The tank is not open, it's not mentioned, so it is assumed to be a rigid tank is a closed tank. So meaning to say, the volume of this water, liquid, and a vapor inside is just equal to the weight of the tank. Because there's no open space or open cover, closed cover or open cover. If there's an open cover, it will change because the volume of the vapor will escape. Okay, so how can you say that the volume of the liquid and the vapor will be equal to the volume of the tank? So it's not. But in here, it's assumed to be a closed, rigid tank. Okay? If it is not mentioned, that is not really open. That's closed. Okay? It's gonna be the technique. If you see a problem like this, a rigid tank, blah, 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 ganon, so you have to treat that as a closed tank originally. Okay? Or else, the formulas will be different already. Okay? Something like that. Or, you cannot compute the correct answer for that. Okay? Now, if we get the specific volume for liquid state and vapor state, of course, we need to get the specific volume on the entire process, which is the small letter V. So this is specific volume for the entire process, V. Okay? Oh my gosh. V, oh my gosh. I have no, ano ba yan? Enthalpy. So V is equals to VF final. Not really final, sorry. Liquid. I told you yesterday, right? I will be confusing the subscript F for liquid because I'm not used to. I'm used to L. Stands for liquid. It's chemical reaction, right? L. Then for gas, G, like that. But here in the, in the steam table, thermodynamics, the liquid is F. Oh my gosh. I don't like really. Okay? I will, misinterpret that sometimes. Just like now, right? I interpret that as a final, V final. It's not. It's a liquid state. So, specific volume at liquid state, VF plus, goodness. Okay? VFG. This one. This is very useful, guys. Okay? N times the dryness fraction. This one. This is the formula so that we can compute. So specific volume of the total or entire process is equals to the specific volume of the liquid plus the specific volume during vaporization stage times the dryness fraction X. That's why it is VFG, meaning liquid to gas. Okay. Now, so we need to find the specific volume during vaporization. But in the steam table, guys, there's no VFG reflected in the table here. Okay? There's no VFG, but there is enthalpy and entropy. HFG, enthalpy, specific enthalpy during vaporization stage. And you have also specific entropy during vaporization stage. But for the volume, it doesn't specify in the table. So what we'll do now? Okay, by common sense or by it's not really that discussed properly, but in chemistry, we go back to chemistry, the VFG is just equal to VG minus VF. That is the specific volume during the final state is gonna be, okay? This is the specific volume at the final state or a vapor state minus the specific volume in a liquid state. So VFG, ganon. Laoy, kaluka talaga. Pentel. Okay, VFG is equals to VG minus VF, this one. Okay, this is specific volume during the vaporization stage. This way FG, okay, is equal to the specific volume during the gas state minus specific volume during the vapor phase. Okay, so that we can substitute that here in this equation here. Okay, like that. Okay, now need to substitute already because we have now the three given: the dryness fraction, the specific volume of the liquid, the specific volume of the gaseous vapor. Now substitute that. We do the math. Okay, like that. So where's the, we do the math, okay? In this is not really requires analysis because you have to substitute. Okay, later we will be having something that we need to think. Okay, by incorporating the previous concepts and theories so that we can solve what is being required in the problem. But in here it's just directly substitution. Okay, but still you should be careful in substituting like that because sometimes you will be wrong or using the wrong formula. Okay, so V is equals to VF. Or VF is here already, right? So VF is 0, 0, 0, 10, 1, 7, 1, 3 cubic meter per kilogram plus dryness fraction X. We already solved as 0.30, right? So 0.30, okay, times VFG. Okay, VFG, this is the VFG. Okay, so specific volume of the gas minus the specific volume of the liquid. So we have already, so just minus or deduct that directly. Okay, so 7, oh my gosh. So absorption process, really, this is the ink and there's air circulation inside my room, and through the process of absorption, it will really absorb the ink and the air will occupy here, and then the ink will no longer, when I write, it will be disappeared. So that's the process, absorption process. Okay, so that's why we have to close every time the cup of this pentel pen before I'm talking, when I'm talking. So that's really my weakness. That's why all my pentel pens are really easy consumed because of that process, absorption process. Okay, again, science, physical and chemical process. Okay, in actual situation. Now, okay, so 0.30 times 7. Okay, wait, we have to deduct this one. 0.6672, and I'll tell you something also. 0.00101. Oh my gosh! 713 is equals to 7.66. 7.66018287. The technique in this, guys, is you have to write all the decimal places. Okay? It's relevant in this topic. You have to write everything. Do not round off and do not cut after the decimal places. Okay? Because it will, there's a slight difference, and then the choices also are very near with each other during examination, something like that, and you will be wrong. So better write all the points, something like that. Okay? Do not cut or do not round it off your answer. Okay, something like that. So this is also cubic meter per kilogram. Okay? Now we have the specific volume of the vaporization stage of this liquid vapor relationship inside the rigid tank is equal to, ganon. So 0.30 times 7.66018287 is equals to plus 0.00101.713 is equal to, we have 2.299. Okay, 2.299 cubic meter per kilogram. Okay, this one. Okay, now this is cubic meter per kilogram. This is a specific volume of the entire vaporization. This is not yet the total volume of the tank. What unit is in the unit? Cubic meter per kilogram. And what's going inside the tank? Have a total mass of 10 kilogram between the liquid and the vapor. So multiply that with 10 kilogram so that you will determine the total volume of the tank. Okay? Because the question is not asking for the specific volume of the entire vaporization during the process or after the process. It asks the total volume of the tank. So be careful. Okay? So what left is the cubic meter. Okay? So 2.299 times 10 is equals to 22.99 kilogram. Oh, no, sorry, cubic meter. Okay? This volume is 22.99 cubic meter. The total volume of the tank in terms of cubic meter. Now, if you obtain this answer, guys, and then there's no like this in the choices, then what's being reflected in the choices are liters, gallons, then you have to convert this by using conversion factor. Okay, so this will go first to centimeter, and after it will go to liter. Since we know 1 liter have 1,000 cubic centimeter or 1,000 cc. And at the time, the liter has also the relationship with gallon. 1 gallon is equals to 3.785 liters. And then you can solve for the liters, the gallons, the cubic meter, the cubic centimeter, and also the cubic feet and the cubic inches in English unit. Because 1 feet, blah, 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 or how many inches, 12 inches, like that, okay? So you can solve. And 1 feet is equals to 0.3048 meters. And the reverse, 1 meter is equals to 3.28 feet. So automatically you can use all the what kinds of unit for the volume as long as you have the conversion factors on your mind. Okay? Sometimes also like that in the choices. Okay, but most of the times it will be given like this already, but I'm telling you to be extra careful, okay? Something like that. So thank you so much for listening for this very basic problem solving of how to use the steam table in a temperature paste. Okay, and then finding the specific volume of the gas vapor and the liquid like that, and then you know the dryness fraction. This is about like this, like chuba chuchu and thermodynamics. Thank you so much. You can subscribe my channel if you want. Then you can also comment down below in the comment section, and you can also share it to anybody else if you want to. Okay, and then if you want also, you can click the notification bell for some newest updates of I Am a Singer, Eternal Voice. Bye bye, God bless everybody. See you later. Oh my gosh.